Okay, so let's get started. In this session, I wanted to go over and tackle an example that has everything in it. I wanted to work on an example that creates an array, prints that array on the screen, and even I want to have a function that takes this array and calculate um, the uh, and takes every element of the array to a power of a integer number. For example, let's create a double array. I'll name it just array with uppercase A. And as we saw in the video, we can initialize it by just putting the numbers here in the bracket. One, let's start 1, 2, 3, 4, and 5. Let's make that 2. Okay, great. The next thing is I want to create a function. I would like the function name to be pow array double. This pow array double, what I wanted to do, I want this function to take the array pointer, which is the name of the array, and then takes the size of the array, and then takes the power that I wanted to calculate, for example, 1 to the power of 3, 2 to the power of 3, 3 to the power of 3, and so on. But I haven't, for the size, I know the size is 5 for this particular example, and I want to take it to the power of 3. Okay, but we need to implement this function. Let's declare it first. So this function doesn't return anything, so definitely it's void. And the name is pow array double. So basically I'm creating my own pow function here for arrays. The function for the first argument takes a double pointer because the array's name is just a pointer. I'll call it ptr array. And then it takes an integer array size. And the next thing it takes is the integer power. Okay, I can take the declaration here and implement the function. To implement the function, what I want to do, I want to have a for loop that goes through every indices of the array and takes it to the power of whatever the integer power is. Okay, for integer, I define integer I equal to 0. I less than array size and I plus plus. Okay, what I want to do in this array is I want to calculate. So if I say in this array ptr array with the index of I, now I'm accessing every individual components of the array, but I wanted to calculate the power, take this to the power of the integer power here. And to do that, I want to create another function. Let's name that function pow. I don't want to use mass library, I want to create mine. The function takes a double pointer and then also takes the power and takes a double pointer and the power and calculates ptr to the power of integer power here. Okay, let me put a note here for myself that this is not complete. Okay, so how to complete this is I wanted to use my pow function. This is basically the method you write a function. You first see what you want to do with that function. Then you declare the function. You see what are your inputs. And then you go and implement the function. So I want the PTR function to take a double pointer and also the power. Definitely the power is what I'm getting here in the function. But what is the pointer, double pointer I want to get here? Any suggestions? So my pow function takes a double pointer and calculates that PTR to the power of integer power. Any recommendation what I should put here? So let's go by the code and see what is happening here. When I is 0, I want the first element to be sent to this pow function. When I is 1, I want the second element to go to this. So PTR array with the index I. But there is a problem, and even Visual Studio shows it. If I hover my mouse, it says PTR argument of type double is incompatible with parameter of type double star. I mean, it says that what are you doing? Double is different than double star. You cannot mix and match them. Okay, so PTR array index I is actually a double number. We have this array, 5 blocks of my, so this array stores, it has been stored in 5 times 8, which is 40 bytes of my memory, which is divided into 5 segments of 8 bytes. And each 8 byte is a double. Now by saying PTR array bracket I, I'm accessing each one of these double. But my function pow takes the pointer to that array. I don't want to send a copy of the array. I want to send the address of that array. So how to send the address? Just to put an ampersand before it. So now this guy here is a double. It's either the first one, the second one, third one, or the fifth one. But this is a double. I want to take the address of that individual one. Then I use the address. And definitely I need a semicolon here. Okay, so let's go and complete the pow function. So void, let me actually copy that here. Lazy. Okay, perfect. So in this function, I'm going to create, let's say, double number. The number we get is actually the dereferenced version of the pointer. If the pointer is an address, if we're dereferencing it, you will get the double number. And I'll create a for loop, int I equal to 0, I less than power, and I plus plus. What I want to do is the dereferenced PTR, which is the number, I want to calculate, for example, if I get x to the power of 5, I want to calculate x to the power of 5 and put it back to the x. So each time in this loop, I just need to multiply number to PTR and place it back to PTR. I can say just this, asterisk PTR equals to asterisk PTR times number. Or this is exactly identical to say asterisk equal. Let's put this into parentheses. It doesn't matter, it will work, but I want to put it into parentheses so I know that this PTR is dereferenced. This is a pointer, and by star I'm dereferencing it now. accessing to the value in that memory address. Okay, great. Let's debug the code and see if we are getting what we want here. I'll put a breaking point. Let's also put a breaking point here. F5. I don't need a memory module here. Okay, so if I step over this line, now the array is initialized. As you can see in the local window, array is 1, 2, 3, 4, and 5. If I step into the function here, and you could look at the local variables in the function. I have an array size, power, and pt pointer to the array. If I step over, you see that the array size changed to 5 because of this. Power changed to 3 because of this integer input. And the PTR array, which is this address, is now pointing to 1, which is the first index of the array. So be careful that when we send the array, we're not just sending the array, we're sending the address to the first element of the array. It's just a regular double. It doesn't make any difference with the double we had last week. It's just the first element in a double array is actually a double variable. Now I'm sending the address of that one to the function. Okay, let's step over to see what is happening. Now I'm going to the power function. In the power function, let's actually step into the power function. In the power function, I have 3 different variables, as you can see, and if I step over, the power and the pointer will be initialized. So pointer, because I sent the address of the first element, now I do have the address of first element here. I can modify that. Let's see what is happening here. If I step over this line, the variable number will be as the value of PTR, which is 1, and I wanted to count to take it to the power of 3. So each time, in this case, it won't matter because it will stay 1. But you see that I is 1, I is 2, and I is 3. And so during debugging this code, I see what a problem is happening. Actually, let me go and step over. I want to stay in this for loop because I want to show you when I becomes 1. Now, the value of PTR array that we sent to this function, now let's step to this function. In this case, if I go to the function, now pow is 3, and I'm pointing to the second because I looped that loop twice. So now I'm pointing to the second, to the third element in the array, which is 3. So what I do at line 23, I put the value of PTR into number. And then each time I just multiply number by PTR and put it in to calculate PTR to the power of number. But there's a problem, you see. I want 3 to the power of 3, but this code runs 4 times and reports 81 for me. And that's not correct. And that's the benefit of debugging. Now I understand where the problem in my code is. If I follow my loop, I'm actually going from 0 to 3, and because PTR is actually PTR the first time, so 1 is already applied. I don't need to multiply it 4 times. I only need to multiply it 3 times. So my loop should start from 1 instead of 0. And that would work perfect. And if I restart debugging, it will fix my problem. Let me get rid of this window. Yeah. Okay, great. Any question up to this point? Okay, let's stop debugging. I want to write a function that logs the array to the screen. So I'll create, what do you name it? Let's say array logger double. This array logger, it takes a double ptr array and also takes the size. And if I wanted to implement the function, so this function should be an easy one. I just wanted to do a for loop. I starts from 0, goes to the array size, and then I calculate. And every loop I implement I, and then a printf statement, which is a %d equals, let's put some space here, %lf and /n. Let's print it to 2 decimal points here. And the first thing is I, because this is the index, and the second is a double, which is the ptr array of index I. Okay, cool. Now I have a function that helps me to log the array. So let me log the array before this power function. And this function takes array and 5 as the size. And also do this after the power function. Let me put something here. So just wanted to add a printf. Divide these two prints from each other. Let me clear the breaking points and compile and run the code. Okay, as you can see, at first array was 1, 2, 3, 4, 5, and then what we did, we used our power array double and takes every element in that array to the power of 3, and we successfully print everything on the screen. Okay, great. What I want to do here is, I want to show you something. Here, I sent the address to a pointer array I, which is pointing to the ith element in that array. And I sent the address of that one to the power function that I just wrote. But if you look at my power function takes a pointer and power. The equivalent thing, the exactly same thing that I could do instead using the pointers was just to say the pointer. But if I say this, if I send this pointer, the problem would be I'm always sending the first element. So I just need to add I here. So if I do that, now each time I'm sending pointer plus I, which should be identical. Let's actually compile and run the code to see if the results are the same. And as you can see, yes, the results are exactly identical. So I could either use pointer and increment pointer in the block of my memory and send the address, send that pointer. So I have a pointer to the first element, increment it to the element that I want, and send that to the function. Acceptable. Or use the bracket to access the value of that element and then send the address of that value as a pointer to the power function. Any questions? Okay, so let's do another thing here. What if I wanted to read an array from a file? Okay, I do have a file here, I guess. Yeah. Just open it first and then put it here. Great. Let me make this a little bit smaller. So I want to read this array, which has 100 elements. But let me actually create the file pointer. I'll name it file ptr in. ptr in. And f open, the name of the file is engm1081.txt, and I want to open it for read mode and semicolon. Okay, the next thing is I want to have a function that reads this file into an array. So let's call that function what? File to array double. And in that function, I want to get a file pointer, which is file ptr in, and I want to get the array. I want to get an array pointer, which is the name of the array. And what else? And I want to get I want to actually report back the size of the array. So I'll create an ampersand size, but let me actually fix this code because we are using variables that we haven't defined yet. Let me actually take this up. So I don't know how many numbers is in the file, so I'll just create an empty array. But what I can do here, I can use hash define. Let's imagine that in the question they tells us that the maximum size of numbers would not go more than 1,000 times. So I'll define a max 1,000. I'll create an empty variable, an empty array of size max. Okay, so now I have the empty array, and I'll create an integer size. I'll create an integer power. So this function, I named it file to array double, and this function takes a file pointer file ptr, and also takes array, which is double pointer ptr array, and also takes an integer pointer, which is the size, because we want to calculate the size. We want to see how many doubles that we are reading and then report it back to the main function. So this function would do that for us. Okay, so now I know what is the function I wanted to use in this code. Let's go and implement that function. So in this function, what I want to do is I want to start reading the file. So first thing, I have to initialize size, because size is 0 if we don't read the file. I'm going to create a while loop to read the file. I'm going to use a scanf function, fscanf function. And fscanf function needs the file pointer, and it needs to know what is the format that is going to read at each line, which is a double %lf. And I want to place it into my pointer array. Remember, I don't know how to emphasize this, but guys, remember that this pointer array that I just got from the input of this function points to the first element of the array. And if I wanted to access following elements, I have to increment it. Okay, end of the file. And this should be a piece of cake for you guys. Okay, so what the first thing, if I read something from the file, if I were able to read one from the file, I want to increment size. But because size is pointer, I have to dereference it first, then increment it. Okay, and then I don't need to read 1 to the first element, 2 to the first element, 3 to the first element. I want to move the pointer in the elements of the array. So what I would do, the ptr array plus plus. So each time I read one line from the file, I'll move the pointer to the next element until I reach the 1000th element, which in this case, we know that the file wouldn't be as big as 1000 element. Okay, so back to main function. If this works, I will have an array of how many numbers we have in this file, 100, for example. I will have an array of 100 doubles, and I will know the size of it because this function, this responsibility of this function is to calculate that size for me. And I want to take everything to the power of 3. I just made a variable to make it cleaner. And let me actually clean my code. So here, declare the variables, and open the file for reading. So file pointer n is equal to this. Use semicolon here. And then what I would do, fill the array using the content of the file. And then what this function would do is log the array to the screen. And then this function would be calculate the power and actually we don't need this log because it will just print the same array. Let's only stick with the second log. We know that that log is already working, so be redundant. Calculate the power. Calculate each element of the array to the power of int pow. Okay, so here it's not 5 anymore, it's size because we just got it from this function, and then this is the integer power. Just want to make my code cleaner, and size. Okay. So if we compile and run the code, nothing's been printed on the screen. Okay, let's debug to see what is the problem. What we are doing here probably something wrong with the function, the scan function that we just wrote. And the rest should be easy peasy. Okay, let's debug it. Okay. So I'm in my file pointer now, and if I step over, let's step into this function. And okay, so after this line, size should be 0. Perfect. Now I need to read every elements in this array and place it into the memory address of the elements in the array. That's the error here. That's the benefit of debugging. Sometimes your code compile and run, but you face this error. And the error takes me back to stdio.h, that I'm violating something fundamental. Let's see what that thing is. Not by reading this code. Even reading this code is hard for me. Okay, I'm gonna close that stdio.h. But I know that the error was in line 60. Can anyone point what is the error? It's so obvious, and we've been using it since second, third lecture video. So what was the job of the ffscanf function or scanf function? They want to scan a double and place it into the memory address. What I'm doing here, PTR array is actually the memory address. I don't need to dereferencing it. If I dereference it, I'm sending the value of that pointer to the scanf function. But scanf function needs the address, needs a pointer. So you don't need to dereference it here. Okay. Control F5 to compile and run. And boom, everything is working. 1, 8, 27, 64. And as you can see, and until 100, which is the 99's index of this function. Indexes start from 0 to 99, which is from line 1 to line 100. Okay, cool. So this was a simple example of how to use functions, arrays, pointers, and files. I wanted to have an example that includes everything. Any questions regarding this example we just went through? So just by raising your hand, show me how many of you have watched this week's video, at least the first one. Cool. Okay. So how do you think was the example? Just... Okay, I got it. Can you repeat the last part about why it's not needed to reference? Okay. It does need actually to reference in the function. That's why I removed that as asterisk here. You see? Okay, so let me rephrase the question. Your friend is asking why we don't need this pointer here, why we need the reference in the fscanf function. So always here in scanf function, this should be an address. What happens if I dereference a pointer? For example, size is a pointer. I dereferencing it. Now I can access to the value. By dereferencing PTR array, what we said, what is PTR array? PTR array is, let me actually put a comment here. PTR, this is so important. I don't know how to emphasize this, is the address of the first element in the array. So where do I want to put the first line? When I read this one, I want to actually put it in the address of the first element in the array. So just PTR array. The difference is star PTR array is the value in the address of the first element. But if in a scanf function, I wanted to access the value, I want to access the address, not the value. That's why I have to go with this one. This is going to be the one that I will use. PTR array, because star PTR array is dereferencing of an address. Dereferencing of an address is not what I want in a scanf function. If I wanted to print it, yes, I want the value to be printed. But if in a scanf function, you remember when we had a regular variable and int I, for example, and I wanted to scan something from the screen, and I say %lf, and here I would say and %i, and %i is the address of variable I. But if I is a pointer, then I just put I here, because I is actually the address, is a pointer variable. Pointers are address. Okay, did I answer your question? Awesome, great. Okay, I have a question. Should we set PTR array to 0, 2 along with size? I would say no, and it wouldn't matter if you do it or not, because what I want to do in this line of code, not in this line, is part of the code that I highlighted. In this part of the code that I highlighted, I read the first element and put it into PTR array. So if I just made it 0, it would change it. Let's actually do it and debug it. I want to show you what is happening here. PTR array equal to 0. I just wanted to show you why this line is redundant. I'll put a breaking point here and debug the code. Let me actually remove this window on the screen. Okay, great. So what do we have here is size is initialized 0. If I step over this line, PTR array, which is pointing to the first element of the array, would be initialized as 0 as well. If I step over the first the condition in the while loop, I'm going to read the first element. You see, just the PTR array is replaced from 0 to 1. It's pointing to the, let me actually open the memory module here. And the name is PTR array. Okay, cool. So if I step over, let me pin it so we have it. We don't need it to be that big. Okay, so now PTR array is pointing to the second element. And here, whatever I initialize it with, if I initialize it with 0, it will be replaced when I read the second element here. You see, the second element of the array. Let me restart debugging. So I want to start from the first one. So first one here, will be 0. As you can see, the first 8 bytes of my memory will be 0 when I'm doing it in line 62. In line 63, if I step over, it's just going to be replaced by 1. So this initializing it as 0 is redundant because I'm going to replace it in this line anyway. Okay. Did I answer your question? So I just wanted to talk to you about something. In the department meeting and in the meeting I had with the dean, the issue was raised that people who engage in the tutorial were being discouraged with by their friends that why do you want to ask questions during the tutorial and let the lecture go on and then we can do it together. But I highly encourage you to ask questions during the tutorial. I won't say the name of people who are asking the questions, and the recording right now is not the recording of the actual meeting, is recording of my screen and what I'm saying. So as you can see, this application, I'm recording right now my Visual Studio and the window open from Visual Studio. So your questions are, so the video that your colleagues or your classmates would watch is just contains the Visual Studio. It's not us in the meeting and talking, and whatever you write in chat it will stay in the class room environment in the Teams, but it wouldn't be on the video and on YouTube forever. So from this point on, just what I'm saying is going to be on YouTube, uploaded on YouTube. Okay, great. Good questions. I'm so happy when you ask questions. I get the feeling that you are engaging with the course. Please, go ahead. Oh, okay. Good question. The while loop doesn't do it. If it's a for loop, yes, the for loop in the third parameter in the for loop would increment the whatever we want to increment. But while loop doesn't increment. What while loop would do, each time it will check this condition to see if this condition is true or false. What does it mean? It will read a line. If that line, if actually was able to, if a scanf were able to read the line, it will return 1, not 1. It will return true. But if it wasn't able, it will return -1, which will be compared by the EOF, which is actually -1, is like in hash defined variable. Well, as long as we're not reaching to the end of the file, fscanf will continue reading the file. But what fscanf will do, it will increment file pointer for you. Each time reads the, you call the scanf function, file pointer will point to the next line, to the next line, to the next line. But I wanted to read the file, whatever is in the double in this case. The double is in the file pointer, but I want to place it in an array, in my array. So I'm responsible of incrementing that array. I know the file pointer will automatically go to the second line, third line, fourth line. But pointer array, if I don't do this and debug this code, let's make sure we put a breakpoint here. Okay, cool. Now each time at that increment, I'm modifying the first element in the array. You see, just the first element in the array is being modified, not the whole array. But if I bring this back and restart debugging, you see the first element, and then each time, let me actually put it as array so we can see it as different elements. What was the name of it? It is. Oh, okay, because we're not, it only shows the local variables and I'm not. And let me, to do this, let's exit the debug, put a breaking point here at this function. So now control F5, no, just F5 to debug. And now I can see the array here, okay. And if I step into the function, oh yeah, the memory module in Visual Studio only shows the local variables, but you get the point. It's, if I don't change the pointer, I'm always modifying the same memory address. Well, actually, that one I can show. To get to the debug menu, and let's show the PTR array. If I step over. Okay, so PTR array is 0, and if I read the first will be 1. Actually, let's remove this line because we don't need it. I have to restart debugging and I don't have a breaking point. Oh, I do. Okay, cool. Okay, now at this line, I'm reading 1. You see the memory address. It's 99D750. And if I step over, I repeat the function, that memory address is different right now. It's pointing to the second 8 bytes after, actually. And this will happen, and so the pointer array will move into the array. But if I don't do this and restart debugging, step into the function. Okay, look at the memory address. It's F0D360. Again, I'm writing 2 in the same memory address. I'm writing 3 in the same memory address. I'm writing 4 in the same memory address. So I'm not filling the array. To fill the array, that pointer points to the first element when I'm reading the first element. It should point to the second element when I'm reading the second element. The only reason I initialized size was I wanted the size to have a value first, and then I wanted to increment that size. And be careful here, I'm incrementing the value of size, not the memory address of size. But pointer array has already a value, which is the address of the first element of the array. Okay. Did I